All right, so quick notes on percent change. So kind of building on what we did in the previous lesson, we learned how to find the percent of any number. And basically, so for instance, if we wanted to find 12% of 40, we could just go 0.12 times 40, and this would give us 4.8. All right. So that was something that we did in the previous lesson, and we learned about tax and tip and discount. So for instance, the general setup for all of these is you have some sort of number, and we're going to call this the original number, our beginning point. And then we have some sort of change to it. All right, we have some sort of change, which could be an increase, could be a decrease. So if we're talking about an increase, it's 1 plus the percentage, and that will give us our final number or our result or our answer, however you want to look at it. If it's a decrease, handled very similarly, but you're going to start off with your number, and we're going to go 1 minus the percent, and then we get our final answer. And some things that represented increases could be tax. It could be commission if you are selling something and you get to add some money to something there. That could be some sort of an increase in your pay. Decreases would be some sort of discount and things of that nature. So, for instance, let's say that we want to know that we want to do 25 is increased by, I don't know, 74%. So how I would set this up is I would take 25 and we are going to increase it, so we're going to plus. And 74%, remember we want to put the decimal in there, that's 0.74. And that should give us our answer. So we're going to do 25 times 1.74. And this will give us 25 times 1.74, 43.5. And we always use 1 because 1 doesn't change anything. You know, if I just had 25 and I just multiply it by 1, then you just get 25 back. You didn't increase, you didn't decrease, you stayed the same. So sometimes on the SAT, they might say a number P is decreased by 32%. And they want to know which of the expressions represents that. Well, P is decreased by 32%. And when you actually work that out, you'll get P times 0.68, which is 0.68P. So here's an expression that shows that P is decreased by 32%. So those are just kind of some basics. So let's get into some actual problems here, see if we can set these up. So example 1, you are currently, so this is now, you're currently making $11.35 per hour. After 6 months, you get a raise. So a raise is an increase of 4%, which is 0.04. Now, you may not have to write that line out. You might be able to just add those together in your head, make things a little bit faster. And I end up getting, when I round it, $11.80. So you have the original, the before, and then you have the after. All right, moving on to example 2. Says you check your settings on your phone, and it says your screen time is, this is right now, it is 3 hours and 20 minutes. Okay, so we're at 3 hours and 20 minutes of screen time. And it says that this is down 17% from last week. All right, so we're down 17%. We were on our phone less. What was your time last week? So we don't know what we were in the past. We don't know the original amount. But we do know that we went down 17%. And You can't really use 3.20, like that won't work for this. So let's just change this to minutes. 3 hours is 180 minutes. And then we're going to add the 20 there. So we're looking at 200 minutes. So we used to be so many minutes, we don't know. We decreased, now we're at 200. So let's solve this. This is going to be x times 0.83 equals 200. And now to solve for x, we're just going to divide. This problem is working backwards. We're going back in time. So instead of multiplying, we're going to divide. We're going to do the opposite. And we do 200 divided by 0.83. And we get x is 240.96. So let's just call that, we'll call that about 241 minutes. Now, if you needed to, we could divide by 60, and we could, 60 goes in there 4 times, so 4 hours, and then there'd be 1 minute left over. So this must be last week, this was this week, and yes, it looks like there was a decrease. Going on down to number 3, the price of Bitcoin. I'm always interested in Bitcoin. I'm invested in some Bitcoin. The price of Bitcoin, April 1st, 2020 was, so that tells me it was in the past. The price on October 1st, so that's now, was 10,623. We need to find the percent. So we're trying to find this thing. Well, first of all, was it an increase or a decrease? Well, Bitcoin has went up. So this is an increase. And what we don't know is we don't know by how much. We don't know that percentage. So we're going to actually multiply this out. We'll distribute it out. We'll get 4138 plus 4138x equals 10,623. And we're going to subtract the 4138 from both sides. And I get 4138x equals, let me punch this in the calculator, 623 minus 4138 is 6485. That's the difference between the two. That's the change. And then we're going to divide both sides by 4138, 4138. And we get, divided by 4138, we get 1.56. 7, keep on going, I guess, whatever. But realize that is, in our equation, that's a decimal. We need to get the actual percent. So we need to move the decimal 2 to the right or multiply by 100. So this thing went up 156.7% had you have bought it in April and then sold it October 1st. Now, there's another formula. In this, you might want to write this down because this is kind of a shortcut. So when you want to find the actual percent of change, there's a couple formulas. Notice that this number right here is just the difference. So you could just do the amount of change divided by, and we divided by the original amount. Okay? And then after that, you're going to have to either multiply by 100 or move the decimal 2 to the right. Okay? So that's just kind of a shortcut formula if you wanted to do that. So for instance, let's just say that, something was $4. So it was $4. Now it's $7. If you don't want to use the fancy equation, you can just say, well, it changed by $3. The original was $4. And so this thing went up 75%. So that shortcut works when you know the two numbers, but you don't know the percentage. I like to use that if I can to save some time. And it seems a little bit easier to work with. A shirt costs $34.45 after sales tax. So we know how much it was after. We don't know how much it was before. We're trying to find the original. We don't know that. But we do know what happened to it. We had a 6% sales tax, 1 plus 0.06, because it's an increase in our original price. So to solve this, you simply divide by 1.06. You do this on every problem in Michigan if you want to work backwards to get the original price. So 34.45 divided by 1.06 equals 32.50. So that was the original price. Now, don't do this. What you can't do is you cannot find 6% of the final price. Okay? You can't find 6% of the final price and subtract to get the original. That doesn't work because we weren't doing 6% of this number. Sales tax was 6% of that number, two different numbers. A lot of kids try this. On the test, I will put that answer on there, and it is wrong. It'll be close, but it's wrong, so don't do that. Example 5. The SAT knows that too. They're going to do it to you. This problem's a little bit trickier. High school football team is made up of 15% of the team are sophomores, 45% of the team are juniors, 40% of the team are seniors, and it says there are 27 juniors. So we know there's 27. Now we don't know how many sophomores, we don't know how many seniors, and we also don't know the total people on the team. Okay? But we can use this clue right here. Because what this clue tells us, it tells us that 45% of the total team came out to be 27. 45% of the team was juniors, and that was 27. So I can make an equation. I can say 45% of the total team worked out to be 27. So this is another working backwards problem. I'm going to divide both sides by 0.45. I get 27 divided by 0.45 equals, looks like 60. So man, there were 60 people on the team. Well, now it's pretty easy to fill in these boxes because if 15% of the team, 15% of 60, well, those were sophomores. So that's going to be 9. And for seniors, if 40% of the team, well, that's going to be 24. And if you do it, it works out right that all of those players equal 60. So the question actually asked how many sophomores. Correct answer there is 9.